Since we took flight, we've witnessed some pretty wild things. Ancient geoglyphs facing the heavens, unknown shipwrecks, and UFO sightings are just a few of the treats pilots get to see. But the sky has another surprise which really captivates me. It's an electrical phenomenon called St. Elmo's fire. Now, most passengers don't have a view out the front of the plane, right? So most of us have no idea this happens. In fact, I asked a couple dozen people before filming this video. No one's heard of it. It manifests in a few ways, but is often associated with static discharges like these. Here's another view. Just look at those fingers. By the books, it'll appear as purple brush-like jets shooting out from the tip of the wings, or even a purple aura around the nose of a plane. It's generally safe, but can disrupt radio communications. And what's really interesting is that this can happen to a plane dozens of kilometers from a storm. It's really wicked stuff. Now, I spent the past several weeks interviewing pilots who've actually seen this, and a bit of time duplicating it here in my lab. I mean, it's a really interesting phenomena that most people will never get the chance to see. So, consider this your invitation. Traditionally, St. Elmo's fire appears on ships out at sea, driven by intense electric fields underneath of a storm. However, the driving force behind its appearance on planes is a bit different. When planes fly through heavily charged atmospheres, such as around a thunderstorm, a plane's metal exterior smashes into charged particles. And that causes a charge to build up on the surface of the plane, exactly like a capacitor. And once that electric potential gets high enough, electrons will literally discharge between the plane to the air. And this tends to happen at points of higher radius of curvature, such as the nose of the plane and also the tips of the wings. And that's because electric fields tend to concentrate at sharper points. That transfer of electrons to and from the air causes the air to ionize, creating that purple coronal discharge. And this process really isn't that hard to duplicate. All you really need is a high voltage DC source, which I happen to own a couple of. For example, this is a voltage multiplier. It produces about 250,000 volts DC out of this little electrode. And here's the same Airbus A320 airliner. Directly mimicking what happens on a plane by charging the plane directly leads to a similar outcome. Notice the wings and the front glow. But the electrode itself can be used as an analogy for an airplane wing being charged to a high voltage, causing open air discharges between the wing and the air. I mean, it's a really beautiful process. The same thing can be seen using a larger Van de Graaff generator. These produce really strong static fields and subsequent discharges analogous to a thunderstorm. Using my hand as a proxy for a plane, streams of corona can be seen discharging from my knuckles. It's such a crazy feeling, and it's really hard to capture on camera. Imagine looking out your window to see this on the tips of your plane's wings. Keep in mind, airliners aren't just sitting still in a static field, right? They're traveling at 550, 570 miles an hour, so they have the potential to slam through a ton of charged air and make way more corona than what I showed here in the lab. But this still doesn't fully explain why the sparks jump across the windshield. Airplane windows are typically made of high-impact glass or acrylic, which are not electrically conductive like a plane's aluminum skin. When cockpit windows collide with incoming air, particularly heavily charged air, ions stick to the surface of the windows and don't distribute to the rest of the plane. Eventually, that charge becomes so intense, it'll have enough voltage to ionize the air and drain to the nearby metal frame. The fractals you see are a natural discharge pattern. The same discharge pattern can be observed by placing a plastic projector sheet on the top of the Van de Graaff and then putting your finger in the middle. Like a cockpit window, the sheet is an insulator and stores a static charge as opposed to conducting it away. Once that charge reaches a critical level, it'll have enough voltage to jump to your finger and discharge. And yes, this is super painful. Please don't try this yourself. Now, I managed to get into contact with a couple airline pilots who've actually seen St. Elmo's fire and the static discharges across the windshield. I had the complete honor of interviewing two of them. The first pilot flies from my area out of Seattle.
I've been flying for about 40 years, about 12 years in the Air Force, and then over 22 for an airline. And encountered static discharge numerous occasions. It's fairly common, in fact. And on occasion have seen what would be considered St. Elmo's fire in the form of the whole glowing outside of the airplane type of visual. I don't even recall if I remember where it was coming from, other than it just seems like the whole front, around the windshield and even the nose, everything just kind of glows. Typically, of course, a lot of times you'll see the thunderstorm builds and then it gets up into the jet stream, and so it gets, they call it blow off, and it looks like an anvil shape.
Yeah.
Generally, we want to go on the upwind side of it, and you will encounter those clouds more often, and it's just the high cirrus type clouds, and those seem to be where you get it the most. A rule of thumb, our procedure is avoid it by 20 miles if you're above, and I believe it's 25,000 feet, and then if you're below that, avoid it by at least 10 miles. So the lower you are, you actually can be a little closer to it just because of the way the energy works.
He went on to talk about other types of weather that cause charge to build up and mentioned that dry snow is known to cause some fairly impressive discharges. Sometimes associated with those discharges comes mild radio interference, but it's usually not too bad. The same interference can be heard when I bring a radio near my Van de Graaff. It's pretty cool because that pulse interference is caused by coronal streams shooting out from the bottom of that sphere. So essentially you're hearing streams of electrons. Now, I also had the pleasure to interview a second pilot, and their experience with the St. Elmo's fire was a little bit different. Snorri lives over in Europe, so we settled for a FaceTime chat.
Yeah, I fly with Iceland Airlines. I fly the Boeing 757 and 767. Fly them both equally, and we fly to Europe and America from Iceland. It forms when we're flying often close to thunderstorm clouds. It was a bluish cone of light coming straight from the nose of the airplane forward for a few seconds, and then disappearing.
You say it actually shot out from the front of the plane?
Yeah, they said it formed a bluish light inside the cockpit and on the nose of the airplane. Yeah. And then moved further away, and for a few seconds, for maybe 10 seconds, they just what's this blue cone of light, and then disappeared. That is really, really rare. So these flashes on the windows are static discharges of static electricity, and we get this great flow. It happens occasionally. I've seen it. Yeah, we see it occasionally. And it's always mind-blowing and mesmerizing seeing those. I have heard some cracking sounds on the radio. That's just because of the charge. You pilots have a special view with these special things happening up front. I felt kind of jealous. Yeah, best seats in the plane. Seats 0A and 0B. Yeah. So, St. Elmo's fire, it's a legit phenomenon. If you've witnessed it either on a boat or on an airplane, I want to hear from you. Leave a comment down below because I'm super jealous. Also, if you enjoyed this video, please consider subscribing and turning on your notifications for new videos. A massive thank you to all my patrons who continue to support my work, and thank you for watching. I'll see you next time, you classy cats.